Hello everyone. Today I will explain membrane potential, including resting potential and briefly mention action potential. First, membrane potential is the difference in electrical charge or voltage across a cell's plasma membrane. This happens because ions are distributed unevenly between the inside and outside of the cell. In a neuron, the inside of the cell is more negative compared to the outside. You can think of it like a small battery. The outside is relatively positive and the inside is relatively negative. Because of this charge difference, the cell is said to be polarized. Now, why does this happen? Because inside the axon membrane, the main positive ion is potassium, K+, along with some sodium, and A+. There are also negatively charged ions like chloride and other large ions that cannot leave the cell. Outside the axon membrane, the main positive ion is sodium and the main negative ion is chloride. This unequal distribution is maintained by the sodium-potassium pump. This activity transports 3 sodium ions out of the cell and 2 potassium ions into the cell using ATP. Next, the resting potential is the electrical potential difference across the membrane when the neuron is not conducting any impulse. In other words, when there is no stimulus. At resting condition, the inside of the cell is negative 70 millivolts compared to the outside. This means the neuron is ready to respond if a stimulus arrives. So in summary, membrane potential is the voltage difference across the membrane when the neuron is not active, and this polarization is essential for nerve impulse transmission.
We will move on to the factors that contribute to the resting potential. As we know, resting potential means that the inside of the cell is more negative than the outside of the cell. The first factors contribute to the resting potential is the unequal distribution of ions in the extracellular fluid and cytosol. As you can see here, outside of the cell has lower concentration of K+, while the concentration of Na+ is higher, and inside of the cell has higher concentration of K+, while the concentration of Na+ is lower. Plasma membrane has more passive K+ channels, which mean the K+ leaks out or move out easily because the axon membrane is more permeable to K+. This means more K+ ion will diffuse down the concentration gradient out of the cell into the extracellular fluid. Thus, this will make the inside of the membranes becomes increasingly negative. You guys may ask why. This is because K+ diffuses out of the cell, means that the inside of the cell will become more negative. Next factors is sodium-potassium pump. As I highlighted here, 3 Na+ will be pumped out of the cell and 2 K+ will be pumped into the cell against the concentration gradient. So since more positive ions are pumped out than pumped in, the inside of the cell will become more negative. As a short recap, membrane potential is the difference in electrical charge between the outside and the inside of the axon membrane. So basically, the inside of a cell is negatively charged, and the cell is said to be polarized because the inside is more negative. The resting potential is negative 70 millivolts. Now let's move to the reason why inside of the cell is more negative than the outside. First, we have unequal ion distribution, which means K+ leaks out, causes the inside of the cell to become more negative. Since the passive K+ channel is greater than the passive Na+ channel. Next reason is because of the large negative proteins inside cannot leave the cell. Next is sodium-potassium pump. This is because 3 Na+ is pumped out while 2 K+ is pumped in, means more positive ions are pumped out than pumped in, causes the inside of the cell to become more negative. The last reason is because of the voltage gated channel is closed. Now, resting potential. It does not conduct impulse, and the inside of the cell is more negative, and the potential difference across the membrane is about negative 70 millivolts.